everybody. So today we're going to look at multiplying rational expressions. So that's two binomials or two monomials, maybe even trinomials. We'll look at a little bit, and kind of simplifying them through multiplication. Okay, so if our problem has, let me double check real quick. If our problem has or contains monomials only, monomials, okay, that means no plus or minus anywhere in our problem. We are going to multiply we're going to multiply the numerator, we're going to multiply the denominator, and then we're going to simplify. Okay, so multiply across the numerator, I'm going this way, multiply across the numerator, multiply across the denominator, and then we can simplify that. Okay, and I'm actually going to show you one little shortcut for simplifying our coefficients, our numbers that are out in front. We actually have kind of a shortcut for that. Okay, so that's the first step if you just have monomials. If we have binomials, a binomial or trinomial, we're not going to go any farther than that. Okay, binomial or trinomial. Okay, binomial means we have one plus or minus, so we have two terms. Bi means two terms. Tri means we have three terms. Okay, so that's going to give us two plus or minuses. Over here we have two terms. Okay, and I'll go through that again as we go. Okay, for this we're going to factor everything like we did last time. Factor everything that we can first, and then we'll simplify. And by simplify, I mean we're going to be able to cross out some common terms from numerator to denominator. Okay? All right, so example number 1. I'm trying to split my screen here so I can see everything that's going on. Okay, so example number 1, let's start with 6x squared y to the third. Okay, and please make sure that you're writing this down. Don't just watch and follow along. It's a little bit more complicated that way. Okay, so we got 6x squared y to the third over 2x squared y squared, and we're going to multiply that by 10x to the third y to the fourth over 18y squared. Okay, so the first thing I'm going to look at, well, are these monomial, binomial, or trinomial? Okay, so do I have any plus or minuses in these terms? No, so this is a monomial. This whole thing right here is one term, all connected, all together. Okay, so these are monomials, so we are going to multiply across the numerator, we're going to multiply across the denominator, and then we will simplify. Okay, but I said I was going to show you a little bit of a trick first. Okay, so I'm going to look at these constants that are out in front first. Okay, so if you wanted, you could go ahead and multiply 6 times 10 to get 60 and 2 times 18 to get 36, but then you're going to have to reduce 60 over 36, which kind of get into some bigger numbers. Not that they're huge numbers, but it's a little bit more work than maybe we want to deal with. Okay, so I'm going to kind of show you a little bit of a shortcut here. Okay, like 6 divided by 2. 6 and 2 are both divisible by 2, right? So if I cross out this 6 and I divide it by 2, I'm going to get 3. And at the same time, I'm going to take this 2 and divide it by 2, and I'm going to get 1. So I've just reduced that fraction. Okay? But now I look here and I see a 3 and an 18. And I know that 3 and 18, so I'm going to highlight this 3 because this is still one of my coefficients, right? We still got this 1. Okay, so now I'm going to look at this 3 and this 18. 3 and 18 can both divide by 3. 3 divided by 3 is 1. 18 divided by 3 is 6. So now I have a 6 and a 1. So once I get to 1, I can't do anything more with that, right? So these are done. These are gone over here. Okay, but I still have this 10 on the right, and I have the 6 down on the bottom. So can I reduce that further? 10 and 6, can those divide by something? Yep, they can both divide by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. So now I'm left with 5 and 3. 1 times 5 gives me 5. And 1 times 3 gives me 3. And that's now already reduced. Okay, so just side note, if I had done 6 times 10 and got 60, and 2 times 18 and got 36, then I could have simplified that. And I could have said, oh, well, 60 and 36 can both divide by 6. I could see that. That would give me 10 over 6. And then 10 and 6 can both divide by 2, so that would give me 5 over 3, and I can't reduce that any further. So, is this terribly complicated? No, not really. I really like this cross multiplying. Just remember that you're always looking from top to bottom, numerator to denominator. So you can go straight up and down like this, or you can kind of crisscross, look at a numerator here and a denominator over here, or like the 10 and the 2, like we could have reduced those to start with to make 5 and 1. Like we have different options there. Okay. All right, so now we're going to look at our variables. So I see in the numerator here I have an x squared and an x to the third. Okay, so when I multiply those together, remember this is x times x, 2 x's, right? X times x, and over here we have 3 x's, x times x times x. So how many x's does that make in all? Got 2 over here and 3 more here, so that's going to make 5 x's, right? Just a visual. X times x is x squared. X times x times x, that's my x to the third. When I multiply those together, look how many we have in all. X to the fifth. So we're going to add those exponents when we go from side to side. Okay? So when I do the same thing for my y values, let me grab a different color here. When I do the same thing for my y values up here on the top, I've got 3 y's right here, y to the third. And I've got 4 y's here, y to the fourth. When I combine all that together, that's going to make y to the 3 plus 4 makes 7. Okay. So then I move down to the denominator. I'm looking for my x's. I see an x value right here. I don't have any here, so I'm just going to bring over that x squared. Nothing to do with that. And then I have y squared times y squared. So I've got 2 y's right here times 2 more, 2 times 2, or 2 and 2, right? 2 here, 2 more here, that makes 4. We don't multiply the exponents, we add the exponents. I apologize, I said that wrong. Okay, so we have this. We are almost done. We already simplified our coefficients, so the 5 and the 3 are going to stay there. They can't reduce anymore. So now we're going to look top to bottom. So top to bottom here, I have x to the fifth, which means I got 5 x's on the top, and I have x squared, which is 2 x's on the bottom. So when we go top to bottom like this, what do we do with these exponents? We subtract them. 5 minus 2 makes 3. So I'm going to have 3 x's. That's x to the third. Now the question is, some of you were missing this on the stuff that we did yesterday, are these x to the thirds, are these 3 x's going to go on the top or on the bottom for my final answer over here? Okay, and what we're going to look for is where did we have more x's to start with? We had more x's up here on the top, so these 3 x's are going to be left in the numerator because that's where there were more to start with. That's where it's always going to end up. Okay. And then we do the same thing with our y values. We've got 7 y's up here and 4 down here, so 7 minus 4 makes 3. So we're going to have y to the third power. Is that going to be sitting on the top or the bottom of our final answer? Where were there more? top, so it's going to go up here, y to the third. So this becomes my final answer. And just for sake of neatness, I don't like the 3 sitting all up there in the front by itself. We usually put it right in the middle. Okay, so that is the process. Again, the very first time always kind of takes a little bit longer because we go through step by step and talk through all of that. Okay, so let's see if we can do another one, maybe a little bit quicker than all of that. Okay, all right, number 2, we're going to have 4a squared b squared over 15a b to the third times 5a to the third b to the sixth over 12a to the fourth b to the seventh. Okay. All right, so still have a monomial, just these single terms. I don't see any plus or minuses. Okay, so I'm going to look at these coefficients out here in the front. Do you see some numbers that are going to cancel? Okay, and again, I don't want to look here. I don't want to see what cancels with 4 and 5. I want to cancel from top to bottom. Is there any number that 4 and 15 can both be divided by? Nope. What about 5 and 12? Can I divide those both by anything? Nope. Now we're going to crisscross. What about 4 and 12? 4 and 12 can both divide by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. Cool. Then we look this other way. Other diagonal, 5 and 15. Those can both divide by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So my numbers now, 1 times 1 is just a 1. You can put that there if you want. We can maybe erase it later when we're all done. 3 times 3 makes 9. Okay, and again, this 1 right now is just kind of holding that spot. Just in case there's nothing else that goes there, we have that 1 that will hold its spot. Okay. All right, so now we're going to do our A's, always going across. Okay, so we simplify the numbers, and then we're going to do multiply straight across the top. I got 2 A's here, a squared, a to the third. How many does that make? 2 here, 3 more, that makes 5. And then the b values, we've got 2 right here, 2 b's, and 6 b's. 2 plus 6 makes 8. Man, I'm writing all over myself with this marker. So we'll pretend that didn't happen. Alright, down here on the bottom we got some A's. How many A's is this? If it doesn't have a number, what's that going to be? 1. Yep, I'm going to put a 1 there because a lot of times if there's no number there, people think it's a 0 and then they don't include it with the other one. So we've got 4 A's over here plus this other one, right? So that makes 5, a to the 5th. And then we've got 3 b's here and 7 here. 3 plus 7 makes 10. Okay. So now we're going to go top to bottom. 1 divided by 9, that's already taken care of. We got our a values, a to the 5th over a to the 5th. Those are exactly the same thing. So they are just going to make each other cancel out. 5 minus 5 is 0. We don't need that in our answer. Anything to the 0 power is 1. Okay, then we have our b values. We got 8 b's on the top and 10 on the bottom. 10 minus 8 makes 2. So we're going to have b squared in our answer. We're going to have 2 b's. Are they going to go on the top or the bottom? Where were there more to start with? There were more down here on the bottom. So we're going to bring this b squared down to the bottom. So we're going to have 1 over 9 from the front. The a's went away, and we've got b squared left on the bottom. Awesome. Okay. All right, let's try 1 or 2 maybe that have the monomial, or not the monomial, sorry, the binomials and stuff. Okay. All right, so this is number 3. All right, so this one's going to say 4x squared minus 4x over 2x squared plus 4x minus 6. And we're going to multiply that by x squared plus x minus 6 over 4x squared plus 8x. Okay, so once I see all of these plus and minuses in here, okay, we're going to factor each individual numerator, denominator. Factor each spot first, and then we'll start crossing stuff out. Okay, so for this problem, I'm going to go down because I don't really have a ton of space over here. Okay, so I'm going to look at just this part first. Okay, just that part. What do these two terms have in common? So they both have a 4 at the front, so I can pull out a factor of 4. Okay. Can I pull out an x value as well? Do both parts have an x value? Yep, so I'm going to bring out the smallest of those because I can't take away x squared from this because it doesn't have enough x's, right? So I always take away the smallest of those values. So I'm going to take out an x as well. I'm going to stick that right there in the front. So I got a 4x in the front, and then we divide. So 4 divided by 4 is 1. So this is going to be a 1. I had x squared, but I take away one of the x's. So that's going to leave me with an x, or 1x. And then I have a subtraction sign. 4x divided by 4x. That's the same thing, right? 4 divided by 4 is 1. X divided by x is 1. So that just stays 1. Okay. So I've got 4x, and then I have a 1x minus 1, or x minus 1. Okay. All right, now we're going to go down here to this piece. Somebody's walking by our house. We have a very good guard dog. King, chill. Okay, can I take out a number from the front of all of this? Can all of these be divided by a number? Yep, I'm going to divide all of them by a 2. Okay, so I'm going to get 2. Can I take out an x from all of them? Say no, because this one doesn't have any x's, so I can't take out an x from any of that. So when I take out a 2, I'm going to be left with x squared. 2 divided by 2 is 1, or 1x squared. 4 divided by 2 is 2 x's, dividing by 2. And 6 divided by 2 is 3. So I'm going to keep the pluses and minuses where they are. Okay. Now the question is, can I factor this a little bit further since it's a quadratic? Okay, can this be factored a little bit farther? Okay, actually, let's do that in 1 second. Let's keep going over here, and then we'll, well, no, let's go ahead and do it. Okay, so can I factor this into 2 binomials? Okay, so the 2 is going to stay in front. That's taken care of. X squared at the front. So what's going to go at the front of both of these? What times itself makes x squared? X times x. Okay. Then at the back, I need 2 numbers that multiply to make 3, or a negative 3, in fact. Multiply to make negative 3, but add to make a positive 2. So the factor, well, 3 is just 1 times 3, right? Those are my only choices, 1 and 3. But I want it to be a positive 2. So is that going to be negative 1 plus 3, or is that going to be positive 1 minus 3? Which one will give me positive 2? This one right here. So I want a minus 1 and a plus 3. So this, I'm crossing this out because this is now gone and replaced with all of this stuff right here. Yeah? Okay. Then I'm going to do the same thing over here on this side. We're going to keep going. We're going to do our individual factoring like we learned from last time. And then, oops, can't see that. And then we'll start crossing stuff out. All right, so this says x squared plus x minus 6. So we're just going to factor that into 2 binomials. X times x at the front. I need 2 numbers that multiply to make negative 6 at the back. And I need them to add to make a positive 1, which is right here in the middle, plus 1. So what two numbers multiply to make 6, but add to make 1? So if you don't think about it, or you can't figure it out, the factors of 6 are 1 and 6, 2 and 3. So which one of those can I add to make 1? Or subtract, right? So I'm going to do this, 2 and 3. If I want it to be a positive 1, do I want this to be a positive here and a negative? Or do I want a negative 2 and a positive 3? Which one will give me positive 1? Not positive 2, negative 3. Negative 2, positive 3 will give me a positive 1. X minus 2, x plus 3. Okay. And then we got one last one. We got purple. We got this. 4x squared plus 8x. So what number can go into 4 and 8? 4. Can I pull out an x value from both of these? Yep, because this one has an x and that one has an x. So we're going to pull out 1x, and then we're going to divide. 4 divided by 4 is 1. X squared, getting rid of one of those x's, leaves us with an x. We have a plus sign. 8 divided by 4. 8 divided by 4 is 2. And the x goes away. Okay, so we've done all the hard work. Now we're just going to cross stuff out. Okay, so here I have a 4. Do you see something that can cancel with? This 4 is going to cancel with this 4 right here. Go away, go away. These are my numbers out in the front. So I had a 4, a 2, and a 4. So the 4's are going to go away to make 1 and 1. So this 2 is going to stay where it is. So I'm going to have a 1 on the top and a 2 on the bottom. And again, the 1 right now is just holding the place. We could eventually go back and erase it if we want to. Okay, do we have other stuff out in the front there? Yeah, we have this x, right? We've got an x here and an x here. Guess what? Those cancel each other out as well, right? X divided by x goes away. So those are just 1s as well. Okay, let's see. Do you see other things that are in common? See this x minus 1 and this x minus 1? Guess what? They go away. Psh, psh. And then we have this x plus 3 right here and this x plus 3 right here. They're going to cancel out. And remember, we're always canceling something from the numerator with something on the denominator. We can't cancel things that are beside each other. Okay, did these cancel right here? Nope, because they are not the same. This one says plus. So I'm going to have x minus 2 on the top and x plus 2 on the bottom. Okay, so I kind of got rid of that one that was out in front of there. You can leave it there if you want, or you can get rid of it. Okay, so my final answer, x minus 2 over 2 parentheses x plus 2. All right. Okay, we're going to do one more just because these take kind of a bit of process. Okay, but I really like that it's just using the skills that we've already learned, the factoring, canceling, things that we learned in middle school even, on how to deal with our numbers, okay? So just stick with it. All right, one step at a time. All right, 10v minus 5v squared over v squared minus 11v plus 18. It's a lot. V squared minus 8v minus 9 over 15v. Okay. All right, so as soon as I see these plus or minuses, I know I'm going to simplify each one of these. So let's start right here on our first one. Simplify the first term. Okay, what do these two numbers have in common? They can both be divided by 5. Can I pull out a letter as well? Do both terms have a letter? Yes. So I'm going to pull out the smallest of those, which is just a single v by itself. And then I'm going to get a parenthesis. And now I'm going to think, what happens if I take away 5 from this? So it's not subtract, we're dividing, right? 10 divided by 5 is going to leave us with 2. And then we had a v, but we brought it out to the front, so that v is going to be gone. So this is just 2 all by itself. Right? Think about this, 5v times 2, that gets back to 10v, right? Then we have a minus, 5 divided by 5, the number goes away, and we're just left with a 1. V squared, but we're getting rid of one of the v's, so that's just going to leave us with 1v, or just 2 minus v if you don't want the 1 in there. In math, we don't usually write that. Okay? All right, now we're going to look at this piece right here. Can I pull out a number from all of these? Say no, no, because there's no number out here in front. So we're just going to factor that. So I need 2 numbers that multiply to make this last term. I need 2 numbers that multiply to make positive 18, but add to make negative 11. So factors of 18 are 1 and 18, 2 times 9, 3 times 6. Which of those would make 11? 2 and 9? But I need it to be negative 11, so they're both going to need to be negative. So v minus 2, v minus 9. Okay, now just a note here. Do you see how these two are not the same? I can make them the same if I divide one of them by a negative 1, but as of right now, they are not the same thing, so we don't want those to cancel yet. Okay, they won't cancel. All right, so we're going to look up here at the top. V squared minus 8v minus 9. Can I factor out a number or a letter from all of them? Nope, because they don't all have numbers, they don't all have letters, so I'm just going to go right to my factoring. I need 2 numbers that multiply to make negative 9 at the back, and add to make negative 8. So factors of 9 are 1 and 9, 3 and 3. Those are my only choices. This is going to make 8. I want it to be a negative 8, so the bigger number is going to be negative. Positive 1 take away 9 will give us negative 8. V plus 1, v minus 9. And the last one down here is just a monomial. It doesn't have a plus or a minus, so we can't factor that at all. That's just going to stay as it is. Oh, somebody else is walking by. Oh, it's the same lady. Don't worry. Same lady walking by. All right, so I'm going to look at the stuff that's in front of the parentheses. I've got 5v over here. Nothing in front, 15v. So I'm going to simplify that. 5 divided by 15. 5 and 15 can both divide by 3. Nope, just kidding. That's a lie. 5 and 15 can both divide by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. That's where I got the 3 from. And v, those are going to go away, right? V divided by v is nothing. So I'm going to have a 1 in the front and a 3 on the bottom. Okay, now I'm going to look at my parentheses. Okay, so we said that this parenthesis is almost the same as this one. Almost, but not quite, right? So what I'm going to do to make these the same is I'm going to bring out, okay, a negative. Bring out a negative 1 from this. And when I do that, here's what's going to happen. I'm going to bring a negative out to the front. I'm going to change the sign on the 2. And I'm going to change the sign on the v. Because when you divide by a negative 1, all you're doing is switching the signs. Okay, so that brings a negative out here to the front on this negative 1. And now these two parentheses are the same. A negative 2 and a positive v. A positive v and a negative 2. Those are the same thing. They're just flipped around. Okay, let's see. What else do we have in common? I see a v minus 9, v minus 9. So those are going to go away. And then we're left with this v plus 1 because there's nothing else that goes with that. V plus 1. Answer. Cool. Okay. Y'all, this is a little bit taking what we did. Oh my goodness. King, chill. He's so aggressive. So aggressive. It's okay, baby. Okay. So we're taking the process from last time and we're including this multiplication part with it, okay? So again, take your time, ask questions. The Zoom is posted online. You can come and find me between 9 and 10 in the morning, which is really early, or you can come and find me between 4 and 5 in the afternoon, which is not quite so early, and I will help you. You can text me, you can send me a remind, any of those things. Please do not just blindly guess. Make sure you've written down the notes and then work through the problems. If you can send me a picture of what you've been working on, you're like, did I do this right? Am I on the right track? I will absolutely help you. Okay? I love you. I miss you. Keep up the great work.